Welcome back to Cosmic Curiosity. Today we're rediving into the heart of a star that's gone supernova and exploring what happens next. The dramatic death of a massive star leaves behind an incredible remnant. It's so dense that a teaspoon of its material weighs billions of tons. Can you imagine? But how does this happen? After a star explodes as a supernova, what's left behind? Before we continue, don't forget to subscribe for more updates on all things space. If you love exploring the unknown and have a burning curiosity about the cosmos, this is the channel for you. Now let's get back to our cosmic mystery. Stars are born from giant clouds of gas and dust that collapse under their own gravity. Over millions of years, these clouds collapse and heat up until they become hot enough to start nuclear fusion. That's when the star begins to shine. But not all stars shine for the same amount of time. A massive star can live fast and die young, while a smaller star can live a long and stable life. Massive stars burn through their fuel quickly, and when they run out, they collapse in on themselves. This collapse is so intense that it causes a supernova explosion, one of the most powerful events in the universe. However, what happens next has fascinated astronomers for centuries. What becomes of the core of this star after it's exploded? Is the answer a neutron star? A neutron star is what's left behind after a massive star goes supernova. But what's so special about these stars? Let's take a closer look at what happens during a supernova. As the star's fuel starts to run out, the core begins to collapse in on itself. The pressure and temperature at the center of the star increase dramatically until it's hot enough to create subatomic particles called neutrons. These neutrons are neutral and have no electric charge. They're made up of 3 quarks held together by strong nuclear forces. As the star continues to collapse, protons and electrons are forced together, and they combine to form neutrons. This process is called neutronization. As the core becomes more and more neutronized, it forms a sphere of pure neutron matter. But this neutron sphere isn't very big. It's only about 20 kilometers in diameter. That's about the size of a city. At this point, the star has completely collapsed, and the explosion occurs. The outer layers of the star are blown away in a supernova, leaving behind only the dense neutron star. But despite its small size, the neutron star is incredibly massive. It can have a mass greater than the Sun, but it's compressed into a volume only 20 kilometers in diameter. Let's take a closer look at the structure of a neutron star. At the center, we have the core. This is the innermost part of the star, and it's incredibly dense. It's made up of subatomic particles called nucleons, which are made up of 3 quarks held together by gluons. Surrounding the core is a thin crust. This is where the nucleons end and the regular atomic structure begins. The crust is only a few hundred meters thick, and it contains a lot of energy. Finally, there's the atmosphere. This is the outermost layer of the neutron star, and it's similar to the atmosphere of a planet. It's much less dense than the crust or core, and it's blown away during the supernova. In addition to being incredibly dense, neutron stars are also incredibly hot. The surface of a neutron star can reach temperatures of 1 million degrees Celsius or more. But despite their high temperature, neutron stars can exist in space without any thermal radiation. This is because their surfaces are so smooth that there's no air or other matter to transfer heat to. Neutron stars are also very strange. Because they're so dense, gravity plays weird tricks on them. For example, time slows down on a neutron star. If you were to stand on the surface of a neutron star, you'd experience time much slower than someone who is far away from it. But perhaps the strangest thing about neutron stars is that they can be invisible. Neutron stars don't emit any light, so they're difficult to detect. However, astronomers have found pulsars, which are neutron stars that emit periodic radiation. These pulsars act like cosmic lighthouses, sweeping their radiation across the universe. If you've made it this far, we thank you for your support. Hope you've enjoyed learning more about these fascinating objects in space. And if you want to continue exploring the mysteries of the cosmos, don't forget to subscribe to the channel and turn on notifications so you never miss an upload. Until next time, keep looking up and stay curious.